Yo, what's up, y'all? Alright, so it's your boy, you clicked on the video, you know who it is, you know what we're doing. Today we're gonna be making a mold simulation, or at least I'm gonna be walking you through compute shaders, how to get started, and ultimately we're gonna be aiming to make a mold simulation just like this one. It looks pretty nice. So obviously there's a lot of colors going on, and basically this is a simulation of 36,000 agents, and we're just gonna be simulating them. Obviously this would be impossible like with our CPU. I mean, I'm running an i9 and I know my computer would fucking kill itself if I asked it to run this. So we're running on the GPU, much faster, parallel and all that fun stuff, which will make it way easier to actually create the all the agents and stuff. So let's first get started with actually, just getting a shader, getting a compute shader on the screen. So for this, we're going to be using this library, Pygame shaders. It's pretty simple. It's basically a Python wrapper. It'll allow me to put a compute shader on screen. Essentially, that's all it'll do. It'll create a basic window, and then it's really easy for working with shaders because I mean, you can handle the Pygame logic if you want, but it'll let you just off the bat run all the shaders and all that. So with that being said, let's get started. So first thing we're going to want to do is we're going to want to create a Python virtual environment, which we do venv in our location. Okay, so after we create our Python venv, we're going to want to cd into scripts, and we're going to activate .bat. So it actually creates and activates our shader. Yeah, so we created a Python venv just so that we don't install to our main directory, like our system libraries and stuff. That'll keep everything nice and organized and keep memory nice and low, so that when I go and delete this later, I don't have to deal with all the residuals of our Python libraries. So the next thing we probably want to do is we want to actually get Pygame shaders. So we could do pip install Pygame underscore shaders, right? We could do that. It is in PyPy. However, this library is no longer maintained, which I know, pretty big red flag. You're creating some project with a non-maintained library, but I mean, this is what I wrote it in, so this is what I'm doing. But yeah, so we can't actually do that because it'll not even work. Modern GL is updated, and the PyPy library actually doesn't have everything that we use in this, so it doesn't have something called the default screen shader. So what we do instead is we want to open up to our Pygame shaders, and then we could get clone, and then we're going to paste the it's the URL from this, so it's the HTTPS, so it's this. We're just pasting that, so we're downloading it, and if we do that, it'll get cloned. Okay, once we're done with all that, we're going to have this. It's going to be Pygame shaders. And all we want to do is we want to take this folder right in here and drag it into lib. It's going to yell at us. And then what we can do is we can actually just delete this. Alright. Now we have Pygame shaders. Now we can import Pygame underscore shaders. And this will actually throw 0 errors. Well, yeah, it'll throw 0 errors, quote unquote. We actually need dependencies too. So this is kind of important here. We're going to want to pip install Pygame, obviously. We're going to want to pip install modern GL. However, before you do this, it's going to have to be version 5.8.2 because, it's no longer maintained. They didn't keep it updated. Modern GL continues to update and evolve, so it just won't work, basically. Modern GL, the new version of Modern GL, which is 5.12, I think, is not compatible with Pygame shaders. So now if we run this, NumPy, you just want to keep doing this till you get all our dependencies, and yeah, and then that's how you kind of set this up. Python main.py. Yeah, okay, there we go. So now our import worked just fine. So now what we're going to do is we're actually just going to rip this, import Pygame and Pygame shaders. We're actually going to just rip this part right here. This will stay the same if you do mainly just shader stuff. You're not going to change this too much. All we're going to want to do here is there's a couple different things we're going to change. So we're going to remove this. We're going to, we create our display. We're basically just going to remove render direct, remove the rectangle, and this should be everything for right now at least. Oh, fragment.glsl. Okay. What do we do wrong here? Alright, I figured out what we did wrong. So this we don't need. that's literally it. So this is now just a basic, I'll just show a black screen, which is all we're really aiming for right now. So now we have our main PY, it runs through the shader, and everything's good. We actually want to create our compute shader. So we're just going to create a compute shader. It's a compute shader, a Pygame screen shader, compute shader, and it's just going to be compute.glsl. And then we want to create a texture, so we're going to do Pygame shaders.texture, right? And this is going to be a screen, and our context with is compute shader.context. So here we're creating our texture, and we're basing it off of screen, which is actually a display. So what we want to do first is we're actually just going to create a default blank surf, which is a Pygame surface of that. And we also want to fill it with black, and we're going to base everything off our blank surf. So now that we've created this texture, we actually want to make it a variable, so we'll say agent, or let's call it agents underscore texture, and that equals this. So now we're just gonna have our agents texture, and to run our compute shader, all we would end up doing is agents texture dot bind 0, which will make sense in a minute, and compute underscore shader dot dispatch that. Okay. Alright, so now we're going to create our compute shader. So if we do new file, compute.glsl, and all we're going to do is we're literally going to rip this code and put it right in here. So version 460 core is the version. You actually can't change this because in Pygame shaders, it requires this version for some reason. I'm not entirely sure why, but I imagine it's just to do with the wrapper and the actual control of it. So this is our compute shader. It basically takes every pixel, sets it to 1, gets the pixel coordinate from the global invocation ID, and then sets that pixel. So what's happening here? Our local size, this is a 8x4x1 work group. And it's basically just how many threads are running in a specific group. Our dispatch calls 600 by 600, so it's going to run the compute shader 600 times, and the compute shader is going to do 8 threads by 4 threads, and it'll just kind of create a work group. Global invocation ID, this refers to this actual thing. So this is our global invocation ID, and it passes, this is dispatch 1, this is dispatch 2 for all of these. So this just accesses that, and it'll basically just tell us the pixel coordinates since we're passing the actual thing, and we're running the compute shader for every pixel on the screen. So that's beautiful. And then we're going to do screen shader.render, and we can run this. The only problem is it's not going to change, even though they're all supposed to be red. And why isn't it going to change? Well, if you look, we're rendering to our agent's texture, and we're dispatching it. So we're actually outputting to this agent's texture, but we're not displaying it because we're displaying Pygame surface. So what we want to do is display dot blip blank surf, and that'll put it on our Pygame display. Okay, basically, blank surf always says blank surf. It would actually just be agent texture dot add surface. There we go, and boom. So now you have a compute shader that runs for every pixel, and it just sets it red. Beautiful. This is a pretty short video. This is just setting up, and the next video we'll actually get into probably the blurring and drawing of agents, which will probably take a long time actually. And then the video after that will be moving the agents based on the heading, turning them based on a sensor, and we'll get more into like the actual like what is going to happen during the simulation that will create this mold-like behavior. So that's it for this video. Thank you for watching. Don't forget to like and subscribe. Yeah.